Hey everybody, sorry I'm late. No quiz. No, definitely a quiz today. Sorry, buddy. And there's not even any free questions on it. QQ. I was getting a pass earlier. What happened? Yep, open notes. All right, let's get into this. So I said I'd talk a little bit more about promises today, so that's this. So here we have like a fake database call, and we could totally consider this like one of our Redis calls if we wanted to, because that's kind of what we're going to be doing. So you don't really have to worry about what it does. It just waits some random amount of time, it using set timeout, and then says, hey, I got an answer for whatever query you sent, and then it returns some object with the answer in it. So if we were to run this, notice so this is all kind of normal so far, except here inside a .then, we're actually running another promised database request. And this should actually work. So let's find out. If I just open up the console here and paste this stuff in. So it says, got answer for looking something up, got answer for looking something up, starting new request, got answer for looking something else, and got answer for, okay. So it actually did wait a little bit in between those, and that's because it sent, if you return a promise, it will actually wait and use that for the next .then. So you can actually do cool stuff like that. Any questions about how that works? I mean, instead of returning just some answer that gets used in the next one, we're returning a promise, and promises just know how to deal with that. Everybody kind of cool with that so far? Anybody not cool with that? Okay, cool. Makes sense. Good. So there's one other thing that about promises that we need to talk about for this next project, and it's called promise.all. This is, I guess, like a static function. It's in the promise class, the same way we do new promise here with a capital P. We do promise.all, and this is a function that takes an array and returns a new promise. And it takes an array of promise-like object or promises or promise-like objects. So let's say we get like, let's just do this part. Let's do a fake DB request here. And then inside of it, I want to take this answer and like do some math or something. And then I want to send off like 4 more requests. So maybe this database request gave us back 4 objects, and we want to do in-depth lookups on all 4 of those objects. So I'm not going to actually put an array into the response. We can just imagine. And I'm just going to set up an array like something like that. And maybe these will all probably be objects, but I'm just going to put a number in there to start. And then I want to do const promises equals an empty array. And this is just lowercase promises, just a regular variable name. We could call it whatever we want. I'm calling it promises because it kind of makes sense. for let I equals 0. I is less than a dot length, length I plus plus. And then I want to do a promises dot push. So I want to add whatever we're doing into the array. And I want to do a fake DB request. And I'm just gonna, since this function just kind of takes a string, right? So I'm gonna put a string in here. You can imagine you would do some like deeper like request based on the ID of each object in the array or something like that. But this could be like, I'm looking up object A of I. And so this should be object 1, 2, 3, and 4, right? So that's the query. And we don't have to dot then this. We could. So I could even say like dot then answer or response handling specific SPEC. God, I can't spell today. And okay, so this will send off a request, and we have a handler that maybe like saves. So this could save each specific database answer we get back. And then down here, outside of the for loop, we want to do a promise dot all promises dot then. Move this dot then to the next line for readability. And we aren't, the dot all doesn't actually give us anything back because it's like which of these promises do you want to put into this dot then? Like which return value of all 4 of these things in here do you want inside this dot then? So normally I don't think it puts any like values into your dot then, but it's cool because we can then do like imagine a res dot send full answer here. Okay. So this should do a specific lookup and handle that specific lookup and do something with it like, okay, I need to loop through all the things, say we got like 4 items back, loop through all of them, create a new database request using the ID of that thing, handle the response, like save this somewhere, save each one of these answers somewhere. And then down here, so actually let me do, I could even save that. How do I want to save that? I guess I can define it here. Yeah, because of scoping, I can define it here. So const all answers. We can just make that an array too. And so this would be like all answers dot push response dot answer. Okay. So this, hopefully, if I wrote it correctly, should work. And because each one of these fake database requests has a different random timer on it, we should actually see things happening at different times. We won't see just like all of them returning at once. So this is kind of more like you're actually going to see it in real code. So let's clear this, paste this in, and run it. So first one's pending. We got the answer. And we got the answer for 1, 2, 3, or 1, 4, 2, and 3. And so these got answer 4. Okay, I'm not showing it. Yep. Let's do that one more time. Okay. So it says got answer, and then it did 4, 3, 1, and 2, and then it said, hey, all queries are done. So, and then it showed us an array of all of the answers, and they're in the, because we pushed each one into this array when we got it back, that's the order that things actually came back. We got 4, 3, 1, and then 2. That's just because we did a random in our set timeout, but this is how we, if we want to like parallelize a bunch of requests, like say, you know, we got our database answer, we need to go look up a bunch more database stuff. I don't want to see like, well, I have to look up 15 users, so I'm going to look up the first user, then look up the second user, then look up the third user, because that's going to take way too much time, right? It really should be like, okay, I got this response. I need to look up 10 specific things out of the database based on this response. Send out all 10 of those requests at once, and then use promise.all to kind of tie everything back together. There is, before promise.all, there, you know, back when we just had callbacks, the equivalent way of doing this, I mean, I'm sure you guys could kind of imagine something like, I don't know, num requests equals a.length, and then like requests left equals a.length. Actually, we just need this one, yeah. So let's get rid of this. So we could do like this equals a.length, and then inside our callback, right? We can do something like if at the very bottom. So this would be inside this one right here. So we wouldn't need this. We could get rid of this promise.all. Let's just get rid of that for a second. Comment it out, I guess would probably be smarter. So we don't need that if we say like let requests left equal a.length. And then inside here, we can just do if, requests left minus minus, if requests left is what, less than or equal to 0. And then do the same stuff we have down here. So this kind of accomplishes the same thing. The problem with this is it doesn't take into account errors. So if any one of these promise.all promises error, you can actually catch it with a .catch down here at the end. So this gives us a little bit better error handling. If one of these things ever errors and it doesn't get to this bit of the code, then it'll never run this actual cleanup at the end, and you'll just be sitting there waiting. You know, you'll just wait forever, because it's like, hey, we never got to 0 requests left. One of the requests bailed on me and never got back, or, you know, errored out, but I didn't catch the error. And so I'm just sitting at 1 request left, and I never, therefore, do our imaginary res.send, and the whole thing just times out in the browser. So promises.all, you don't have to do all this stuff with it. Get rid of all of this crap. You can just do promise.all, and it'll give you better error handling. And also, you can, this is still a promise. You can return this to other stuff, and other things can wait for all of these to finish if you want. I don't think we have to do that for this project, but that's a quick rundown of promises.all or promise.all. It's going to be hopefully useful for you guys. I don't think we really ever have to do this, but maybe like once. But this stuff, I think you're going to want to do in like 2 or 3 places. So any questions on promise.all? Feel like
So if you had
go ahead.
other promises for that first fake DB request, it would be outside of that promise. So you'd have like the big promise block, I guess. It's like 2 or 3 .thens or something that aren't nested. And then say on like line 51, would you declare promise.all, or would you have to do it in like another then?
Promise.all has to have access to the promises array. So if you did it out here, you'd have to move your promises array outside of this scope, if that makes sense. The only reason this function here can see that kind of stuff, so this code is in the exact same scope as the promises code and the for loop and all that. So this part works fine. This part being able to actually read all answers, the only reason that works is because this function here was created within the scope where all answers was already existed.
Okay.
This top level one and its dot then, yes, you could, for example, do return this, and then you could move this out to here, and that would kind of work. The only problem with that is this now needs to be defined way up here. And then all of this stuff can still access it because this was defined, this existed in the scope where this function was defined and in the scope where this function was defined. So this works, this can conceivably work the same way.
Okay. So it's better to have, I guess, the nested thens or nested promises.
I think so. I mean, these are functionally equivalent. It's just a matter of where do you want like your scope to dry up, basically. This is a little bit broader scope. If it's down here, it kind of keeps everything encapsulated together, and you don't need to return this promise. You can just, you know, have all of this all part of the same bit of code.
All right.
So I don't know. I like doing it this way a little bit better. As opposed to like building a promise inside here and then handling it as a dot then on the main database request. It just flows better in my mind if this sub thing is all inside the area where you got the request back or whatever. But
okay.
I don't know.
Cool.
Functionally equivalent though.
All right, thanks.
Any other questions? I guess I can get rid of that code. No other questions. All right. So I guess I'll move on to just, we talked a little bit about Bluebird on Monday. And I wanted to talk about just how it works under the covers. Kind of, we can kind of imagine if we wanted to write this ourselves, what it would look like. So most of these things, like for example, the client, right? You make it like a fake client object. The Redis client just is something like this, and it's got some DB request, and then some other something like that, and each of these actually points to a function. Let's call this like a write to DB and read from DB request. So reading from the database, sometime, I mean, I guess we'd really just want like the query, right? What object to read. And for this one, we want like object to write, thing to write. Or this is gonna be like destination, what to write. And so inside each of these, it's going to do some stuff. And both of these in the Redis client also has a callback and an error back, but I'm not going to get into that. So this last thing on all of these functions is a callback. So it's going to like do some database stuff. And just a callback, because callback like is going to be, for this one, it's going to be like the actual object, like stuff we read. And this one is just going to be callback true or something like that. Like, yeah, it worked. Okay. So we got this object. It's kind of our fake database, fake Redis client. And then we want to make promise versions of these. So this is what Bluebird is doing. It's going to like for key in client, and it's going to say like if, what is it, type of client key equals function. So it's like, all right, if we're looking at a function, and it probably does some other checks in here. And then it tries to make a new version of this. So if this key is, you know, read from DB request, and this is write to DB request, it wants to make a clone of this function that's stored in async. So client of key plus async. So this will make like a basically an async version of each of these, right? It'll do something like that. And we want to make it equal to a function. And it's going, this function's going to take in, this actually needs to be a real function, doesn't it? Because it doesn't know what arguments it has. And we need to use arguments, right? So we have to make it a real function because we need to use the arguments keyword, because Bluebird doesn't really know how many of these things it's going to take in. But, all right, so we're going to have to use arguments. I'll get to that in a second. And we're going to want to create a new promise, right? So new promise, resolve, reject. And inside here, we want to call client of key. What do we want to call it? We want client of key of arguments, and we can spread the arguments. Hey. So this will take all the things in here, and instead of just passing it in as one parameter as an array, it'll actually break it out. So if we pass in these two things into our function here, arguments will be an array of two things. So arguments equals right. So it's going to look something like this. And if we do this spread operator, it's actually going to pass in destination, comma, what to write. It's not going to pass in an array with those two values in it. Can I scroll down a little bit? Yep. Sorry. So we're trying to create a new promise. We know that we need to call client sub key, which is going to be one of these two things. And we know that we need to spread our arguments out so that it will actually put them in as comma separated parameters, however many parameters are in arguments, you know, it'll make that many parameters instead of just passing arguments as an array. And we need to take this answer and we need to call resolve with it. So now this, I can actually spell this out to make it a little bit easier to understand. So now inside this promise, when we get the answer back from the underlying function, we call resolve, and we can return this promise. And that's pretty much it. So this is kind of what Bluebird does. Now, Bluebird will also try to pass in error callbacks. So if each of these actually has an error, then inside here it may, oh wait, no, this is not how it works. I'm sorry. Comma, and then we have our actual function in here. And so this is going to take the response. Because remember, the underlying thing takes a callback, right? And so our function doesn't take a callback, but this client dot write to database, it takes the destination, what to write, callback, and error back. So the callback here is going to be resolve with the response. And if we have an error back, so we can pass this in, and remember in JavaScript, we can pass in more arguments than the function uses, right? So if we pass in If it doesn't have this error back parameter, if it's just that and we pass in an extra function pointer, it'll just never get called. But if it does have an error back, then we can make sure that we're handling that correctly by doing an extra parameter here and reject with the error. So this is how it takes something that has some arguments and then a callback and then an error back and creates the same thing, but just returns functions. So now down here, that just returns promises. So now we can go client dot read from DB request async, and it will only take in the, whatever object to read, Bob, and it'll return a promise. The ... spreads. So, but yeah, that's not very useful. It's called the spread operator. So in this case, so normally if you were to have an array, so like A equals 1, 2, 3, 4, and then we were to call some function f and pass in A, or f and param. Then this param will actually be the array 1, 2, 3, 4. But if we do f ... A, let's change this to A. I'm just pseudocoding the hell out of this. If we do f ... A, that's equivalent to calling f A sub 1 or A sub 0, right? It starts at 0, A sub 1, A sub 2, A sub 3. So it actually breaks it out. Scroll down. Sorry. Let me fix that. How do I need to move this up a little bit? Oh, come on. Work with me. There we go. So this spread operator here, instead of just passing in as one entire array in one parameter, it actually breaks it up so every element gets its own parameter. And since arguments here is an array, it would be something like this. And it could just be an array of one element, but I don't want to have to, there are other ways to do this, but this is a lot cleaner. So instead we could do a dot call and then pass in a scope and an array of arguments. So a function dot call is a way to invoke a function. Instead of just having like function with parentheses, it has a property called dot call. You can use that, and instead of passing in, there's two of them, there's like apply and call, I can't remember which one's which, but one of those two, you actually pass in an array like this, and it knows to break those out into parameters. But now that we have the spread operator, thanks to newfangled JavaScript stuff, we don't really need to do all that fancy dot call and dot apply. We just call it the regular way and use the spread operator at our level to break it out. So I can actually try and make this a little bit more readable. Let's make this call back equals this. Error back equals this. And then we just call this with callback and error back. So this is us calling the underlying function. We're passing in all the arguments we were given, and then we're tacking on 2 extra arguments to the back, the callback and the error back. And all these do are resolve the promise that we've returned or rejects the promise that we've returned. So this is pretty much this is almost exactly what Bluebird is doing under the covers. We just don't have to write this code, and even though the Redis client here is something that generally takes callbacks because of the way Bluebird does this sort of stuff, we end up with async versions of all the functions that we can then call and actually get promises back and do the fancy promise.all stuff like we're doing up here without having to do any extra boilerplate legwork. So that's why we're using Bluebird. And if we go look at the project 5 server, promisify all, Redis client, and Redis multi, and we pass in the prototype just because that's what Bluebird tells us to do in their documentation, whatever. And then we actually get these async functions here. So the regular client.hmset without async would have 2 extra callbacks at the end, the callback and the error back. Because we're doing async, we just pass in the key of what we want to set and what we actually want to set into that key. And when it's done, we have a .then and we're good to go. Any questions? Anybody?
So that .then bit is what we did earlier, or is the client.hmset async?
This is created because we ran Bluebird over the Redis library.
And that's what we just, I guess, quote unquote, defined.
Yeah, the stuff
pseudocodally.
What this is doing is this for loop here, basically.
Okay.
I'm sure I'll have them after I start digging into the project. Yep. So something that you might have more questions about, perhaps, is our next topic that I want to at least touch on a little bit, and that is, what the hell is Redis? I'm sure you're all super interested to know. So if we go to redis.io, where they have a nice little interactive tutorial for you, they have great documentation, the full list of commands here. Reddit's little brother, Redis. Reddit's little sister, come on now. And so here's kind of all of the different commands that you can run in Redis, and gives you an idea of what they are supposed to be doing. Now, most of these we're not going to use, like ACL stuff. We're not going to mess with ACL at all. And if we get to like client type stuff, we're not really going to mess with any of that either. But if we filter this down to just hashes, for example, here's some stuff that we would be using for hashes. And let me take a step back and go to our documentation again. There should be, yes. Ugh, frog. Okay, so this is an introduction to the data types that are in Redis. So it can hold binary safe strings. It is not a plain key value store, but at the top level, it doesn't have tables. So in a regular SQL server, you have, a database, and inside that database, you have tables, and inside that table, you have rows and columns and all that fun stuff. The top level of a Redis database is just a bunch of keys and some sort of data type value. So the most simple is just a key and a simple string value. So it's just like the curly brackets that we use in JavaScript. It's, some string key and some string value. It's binary safe. So if you wanted to take the binary data of a JPEG and shove it into the value inside a key value pair in Redis, that would work just fine. It'll totally work like that. And then later on, you can pull that image out and send it straight down the wire to the client, and they will actually render the JPEG image. So all keys are strings, and then you have a couple of different things that are values on the other side of that. So the first one we just talked about, the first type of value is a string. The second is a list. So this is sorted according to order of insertion. They're basically linked lists. So this is actually an ordered list of strings. You can have, so you get this back, and when you use the Redis client in Node.js, you'll just get a square bracket array. If you say, hey, give me key 1, 2, 3, and the value in key 1, 2, 3 is a list, you're going to get back an array. Sets, however, are unsorted string elements, and they are unique. So this is actually pretty useful. We use sets in our project to store like all of the student usernames that we have. So the username can only be in there once. So if you try and add the same username to this set of all usernames, you're going to get back a, hey, I didn't add anything. It was already in there. And then you're like, oh, well, if you didn't add anything, then no, you can't create that user. That user's already taken. So you just kind of try and put a username into a set. And if it comes back and says, nah, it's already in there, then you tell the client, no, you can't create this user. If it says, yeah, cool, I added that to the set, then you go in and you're like, okay, cool, let me create the rest of the object for that user then. So you don't have to do like a lookup in a set to see if something's in there. Most of the time you just kind of attempt to write into the set, and if it's already in there, then it'll tell you so on the way back, and then you go, okay, well, I'm not going to do any other work then. But it is just string elements. So we wouldn't want to put, we could put a whole JSON object in here, but each one of those aren't guaranteed to be unique. They may be ordered differently, but store the same exact data. So we'll use sets as kind of like a primary key, a list of primary keys that then point to other sorts of objects. Sorted sets, we don't really use at all. Hashes, this is where we're going to store most of our data. It works just like the curly bracket stuff in JavaScript. So you have a top level key in your database, like this is my hash. And then in the value that points to is another set of key value pairs. Now you can't nest them infinitely deep. You can only go one deep with that. Does that make sense? This will make a little bit more sense when I start typing stuff out. And I think pretty much this is all we're going to use. We also use numbers, but the numbers get stored as binary safe strings. And Redis is smart enough, so we may have a count. We're going to have a counter in our database, and it's just going to start at 0. And we tell Redis to just increment this counter stored in key, like number of students or whatever. And it goes, okay, cool. And it gives you back the new version after it's added 1 to it. And if that counter didn't exist, like you just created the database and it doesn't have a students counter, when you increment it, it'll actually just set it to 1. It'll be like, well, I didn't find it, so I assume it would have been 0 because I didn't find it. So I'm going to go ahead and create it, set it to 0, and then add 1 to it. So increment, and when you look at it, I think it still comes back as a string, but it's an actual number that Reddit understands and can add and subtract from. Very long strings are not a good idea. So we don't want to store a bunch of data or very long keys are not a good idea. Values, yeah, sure. Very short keys are often not a good idea at all either. So for example, if you wanted to store user 1000 and then their followers as a key, you should instead write it with user : 1000 : followers. Now we will actually do this. We're going to use colons to namespace stuff out because it's all one big top level thing. So if you have an object for every student, say you had like, you store each one by the username. So let me go back and just type a little bit while I'm talking instead of hand waving. This might be a little easier. So this is our Redis database. And let's just imagine for now that it's just key value pairs like this. Why colon specifically instead of, no real reason. It's all just keys at the end of the day. So yeah, no real reason. So inside here, let's say we're just storing students. And so we have a username, Bob, and it's going to have like a name, some object here. And that object might have like a name, password hash, salt. Other stuff, whatever. So we got Bob in here. And I'm just going to actually get rid of the quotes around this to make it a little bit easier. So we got Bob in our database, and this is a top level key. If we go ask, hey, database, is there a key that's called Bob? It'll be like, yes. And so let's call this one Rob. So This top one, it's Bob, and we will get a hash data type back because it points to a hash. We could also have, let's see, what do we need? Users, right? And then this could actually be a set, and it could store Bob and Rob. Because when we want to say like, hey, I need to be able to look up all of these current users that are in my database. I don't want to roll through all of the keys in the Redis database. Instead, I want to get, all right, hey, users, look up the key users. And when that comes back, I have a list of all of the actual users that are in my database. So this is a little bit faster. And guess what? This is when we would do a promise.all, right? So first we'd be like db get users dot then array of users for loop over array db get user array sub I or something like that. And then promise.all, we're done. Something like that. So instead of just saying, hey, database, give me every single key that you have in your database, and then I'll try and figure out which ones are users and which ones are grade objects and all that other crap. I'm just like, oh, hey, I store a set that has all the users. And so I just go get that set first. And that works out great. The one thing that wouldn't work out great, unfortunately, with the way that we have this stuff laid out is what if I create a user whose username is users? So I send in like a request. I want to make a user with the username users, right? What's this gonna do? Well, if our code is kind of dumb, I mean, if it's kind of smart, it will be like users is a reserved keyword. You can't use it. We're already using that in our database to store other stuff. If it's kind of dumb, it'll be like, oh, let me overwrite users with assault and hash and name. So it'll just be like, oh, well, you want to name users? All right, well, let me just write this into users, and then our whole database is broken. So that's not great. That's the dumb way to do it. The semi-smart way to do it is to have something in your like registration code that's like, no. Just hard code it in there. Like, no, you can't use the username users. How many more times can I say the word use? You cannot ask for the username users. That's reserved. It's right out. You can't have it. That's kind of better. What is even better than that is if we make these actually namespaced. And I'm putting quotes around them now just to denote like that colon is inside of the string. So this whole key is user colon Rob and user colon Bob. And down here, we still don't have to put the user colons up here in the set of users, because we just get user colon array sub I. Kind of, sort of like a MySQL table, sort of. Is Redis any different than MongoDB or Firebase? I've played a little bit with MongoDB, and it is a little bit more like Mongo. That I think all three of them are NoSQL. I think Redis and Mongo were kind of like, they were created around the same time to fulfill some of the same goals. Haven't messed with Firebase. And namespacing works kind of sort of like a MySQL table if you squint really hard, but you're kind of doing it yourself, right? So we have these keys at the front here, and that means that even if somebody wants to create an object with the username users, it would just do It would do something like that. And so this would not actually step on our regular user's set. It would create its own little key. And yes, there is a way in Redis, before you ask, there's a way to like Redis search all keys for user : star. Yeah, you can do that, but it's not near as performant. Can you nest namespaces? So this namespace, we just made it up. We just tacked a string onto the front of this. So you can put whatever you want. This could be an underscore. This could just be like user : users, or user : some other string : Rob. It really doesn't matter. It's just when we create this thing in the database, we're like, take the username and add users : into front of it before you save it as the key value pair. So you can put whatever you want in there. We just use colons because that's kind of what the document is. Yeah, it's not built in at all. It doesn't recognize that. As far as the database is concerned, this key is no different from this key, right? They're all kind of the same thing. So yes, you can search for all keys, search all keys in the database for user star, and then you don't need this set at all. But then you also have to look for, you have to search when you're like returning all the users. You also have to search through the whole database to see if a user exists already. So it's a little bit slower. Now with the size of database that we're going to be playing with, slowness is not going to be an issue, but I very much prefer that you actually use a set and then look up this set. And then that also makes you deal with like nested promises, like this whole thing here. I want you to be able to do this. So I don't want you to do a look through all keys for user star. I want you to have a set that holds all the usernames. And then as you go through it, you just say, hey, get me this specific thing that starts with user : and then whatever answer you got back. So user : Bob and then user : Rob, because that's what we looked up first in our database. So that's the first half, right? That sets, and that is these little hash elements here. And that all seems to work just fine. The other thing that we do is things without explicit usernames. So grades, for example. So down in the same database, we're also storing numbered objects. And so every time you create a grade in our project, we just say, all right, well, how many grades do we have? Bump the number up and use that as an ID. So this is kind of like your primary key in a database where you just like auto increment the primary key in MySQL. So inside our database, we also have grades, and it's just going to start at 0. In fact, it could just be entirely empty because when we increment it, it'll set it to 1 anyway. But let's say it starts at 0. And then we want to create a grade. So the first grade we create, we're going to add 1 to this, and we're going to make a grade : 1. And it's going to be a hash, and it's going to have like the student, the ID of the grade, and then the student ID, and then the type of grade, and then what the max value was and what they actually got. And I think those are all the keys that we have inside grades. So the student ID points, it would be like Rob or Bob or something like that. The ID here would just be 1. So it's a backwards forwards kind of reference. Type would be like quiz or test. Max would be 100, and then this would be like 95 or something like that. And so every time we want to make a new grade, we just increment this grades, and the database will give us back. So db anchor grades. And it's actually an increment function, isn't it? So it's what, like client.anchor async grades dot then, and it gives us back the new counter. And when it gives us back the new counter, then we do like client.hmset async grades : plus new counter. That's not right. And then, the grade object, something like that. So this would be how we would actually save a grade into our database. instead of having a set, we just have counters that starts at 0, goes to 1, 2, 3, 4, and every time we make a new one, we just go, okay, well, this one's now going to be grade 2, and this one's going to be grade 3. Yes, you can delete both of these types. You can delete users out of our database, and if you were to delete Bob, you would also have to remove him from the set. And if you were to delete a grade, no, please don't decrement this counter. We would just have a hole in our counters somewhere. Like, if we tried to delete grade number 2, for example, and grades now goes back to being 2 because we subtracted 1 from it, then we would make a second grade 3. Does that make sense? So if we had all of this together, right now, our grades counter would be 3 because that was the most recent thing we returned. We did this increment thing down here. We got a new counter back. That new counter was 3. That's why we created this. So therefore, grades counter is currently 3. Okay, cool. If we wanted to delete grades 2, cool, we can do that. And then we want to, for some dumb reason, we want to subtract 1 from grades because now we only have 2 grades, right? It's not, why wouldn't we subtract 1 from it? And then we go and do this increment stuff again down here. It adds 1 to grades, and new counter is 3, and then we have saved over a grade in our database. So we don't want to decrement stuff. We want to keep it at 3. And if there happens to be a hole in our database, our code needs to be able to handle that. So eventually you might have grade 1, 2, 5, 7, 8, right? You might have holes all over the place, and that's fine because eventually, if you wanted to look through all of the grades, you do something like client dot get async grades. So we aren't incrementing it, we're just getting the value of it. And it's a counter, and it'll be like 3 or whatever. And we want to do 4, 0 to counter client dot get what hash or what async. I forget what the command is to actually get the value of this thing. But yeah. And then this would be grade colon, I. And dot then result. And here we just need to be really sure. Oh, I need curly braces. Make sure you got something back because we're sending off a request for everything 0, 1, 2, 3, 4, 5, 6. And I think this would actually start at 1, shouldn't it? Because we're never going to have a grade 0. So it's just going to do 1, 2, 3, whatever, it'll count. It'll send off a request for every single one. And if we have a hole in there, then we need to make sure that this dot then accounts for that. And I don't remember if it's a dot then and the results are like undefined or false, or if it's like a dot catch. So that's something we'll have to figure out a little bit later together. So these are the 3 types of data that we're going to be using. There's regular key values. This one's a number and we can increment on it, but it's still just a regular key with the string value. There's these hashes, which are almost always going to have some namespace. And I put quotey fingers, air quotes around namespace because it's just us adding strings to the beginning of the key. It's not anything special inside the database. And then there's these sets that are unique. They're not ever going to come back in a guaranteed order, but you at least know that everything is in there once and only once. Okay, that is the very top level rundown of Redis. If we want to go play a little bit with Redis, I would suggest, so that number 3 is still stored as a string, yes. But when you do increment on it, it's nice enough to do that conversion for you. And I believe if you were to do a get async here, I believe the counter might be a string. I can't remember. The Node.js bindings for Redis might convert this counter into a number for you, but you might need to convert it into a number yourself, which I think is like int val or something like that. There's a way in JavaScript to convert a string to a number, but you just might want to console log what you're getting from the database to make sure that things look right. And if we go back to, where were we? Full list of commands, and let's just go look at, and I'll give you guys the quiz in a second, but let's do like hgetall. And every one of the pages that they have has an interactive running in JavaScript in your browser. If you refresh, it'll like lose all of its data, but it has an interactive command line. So we can actually type into a real Redis database here. So I can do, let's see, what was this? So they did a hash set with a key my hash, and the field 1 was hello and field 2 was world. Okay, so it wrote 2 sub keys into this hash, one with each command, and then it got the whole thing, and it said field 1 was hello, field 2 was world. The Node.js bindings for Redis will actually bundle that up into like curly bracket key value pairs, but I can do like hm set, which I think is another command. This is actually setting multiple fields at once. My, h2, and then I want to do f1, a1, f2, a2, and then I do hgetall, h2. And it says, hey, the first key was F1 and the first value was A1. The second key was F2 and the second value was A2. I can even do other commands that aren't even part of hashes. So like here I did hmset. I'm not on the hmset page. I'm on hgetall. You can run any of the Redis commands, or at least any of the ones that we really worry about. You can run them all here. You can do like get. So I can do like anchor counter. And then I can do get counter. And it'll say, hey, it's 1. And then I can do, I think it's what, set counter 5, and then anchor counter. And now it says it's 6. And if I do get counter, it is now 6. So I can do all of these things and kind of play with it here. When you install Redis, you also have a Redis CLI that you can run and do these same sort of commands on your box talking directly to your database. So let me ask you guys this. Would you rather see me talk about how to do this database stuff specifically in Node.js, or do you want me to show how to do it directly on the database? Like, here's the MySQL equivalent commands to do all these things, and then take a step back and show how to do all those same things in Node.js. Is this thing more confusing than the JavaScript code I was just writing? It seems like it might be. Okay, we got 1 vote for Node. A little of both. Node. Like to see both if you have time. Okay, cool. The JS is more confusing. Both. All right. So the one problem with the JavaScript is because it's a JavaScript binding, the Redis library in Node.js doesn't have documentation for how Redis works. It's just mapping whatever commands Redis has under the covers into a JavaScript binding. So if you're looking around on the Redis page, you're going to get the raw MySQL equivalent syntax, and you're going to have to kind of like, okay, well, how is that exposed through the Node.js thing? So I'm going, I guess, to try and do a little bit of both. And I started out with talking about just how we're using these things, but I might go off and do some completely different things in a Redis database, just to give you an idea of like, okay, when do you use this tool? When do you use that tool? And I'm going to kind of have to make it up as I go. Because like, who am I kidding? I'm not going to prep that much for the next class period anyway. But I'm going to at least have an idea of what I want to do. And I'm going to do it all. I'm going to try and do it all directly in Redis commands over a CLI interface. I don't think there is Node.js Redis. Redis through npm. So if we go look at this package that we downloaded, it actually, okay, so util. Apparently you don't have to do Bluebird anymore. There's just a util function or something. Util.promiseFind methods available in anything greater than V8. So we don't have to use Bluebird or BlueJay or whatever the hell it is. But yeah, this library is a one-to-one mapping of the Redis commands. Each Redis command is exposed as a function on the client objects. All functions take either an args array plus an optional callback function or a variable number of individual arguments, blah, 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 blah. So it does not tell you what all the commands are. It says, hey, we're mapping these things. You're going to have to go over there and look it up. So that's why it's kind of, that's why I don't want to teach entirely Node, because then when I'm like, all right, now you guys go figure it out and stop asking me questions, you're going to be like, I have no idea how I figure this stuff out because the stuff I'm reading in the Redis documentation doesn't make any sense to what you just taught us how to do. So I'm going to have to do a little bit of both. I think I'm going to have to teach a little bit about just doing stuff through the Redis CLI and then go back and convert those calls, that exact same logic, into a set of function that does the same stuff in Node. So I think both. Although when I convert it to Node, we're going to be using promises, and so that's going to add a little bit extra complication and confusion to it. But honestly, we're going to need to get real friendly with promises anyway. So it just is what it is. Okay. That's, I think, all I got now. Anybody have any more questions before we drop over to the quiz? Nobody. What's today's date? What quiz are we on? The 21st? Would it be possible to drop your example code files you write in class in Slack so we can look at it ourselves? Sure. Which ones? I guess you guys want this stuff and this stuff. Although I did delete and recreate some stuff, but I can poke both. I can put both of these into Slack. Sweet. All right. I can do that. All right. So here's our quiz for today. It is 12 points, and the access code is nasty big pointy teeth. All lowercase with spaces. I was going more for the Holy Grail reference, but you know, whatever. It's also slightly Halloweenish. Run away! All right, I'm gonna let y'all take this quiz. I'm gonna hop on out of here. I gotta run to the grocery store real quick, but I will post this code before I go. Enjoy your afternoon, ladies and gentlemen. And I should be around tonight if you have any questions. Peace.